Imagine peering deeper than ever before, beyond atoms and quarks, to the very fabric of the universe itself. At this incomprehensibly small scale, known as the Planck scale, the familiar rules of physics begin to blur. Could these tiniest building blocks of matter harbor something even more extraordinary, like a black hole? Black holes, those colossal celestial phenomena that consume stars, might also exist in a form so small and elusive that they fit within the particles composing everything around us. This idea isn't mere speculation. It arises from the fascinating intersections of quantum mechanics and gravity. What would it mean if this were true? Could each particle be a gateway to hidden darkness? Today, we embark on a journey to explore this profound possibility, unraveling the mysteries of microscopic black holes. Let's begin by delving into what these fascinating entities might be, and how they could redefine our understanding of the universe. Microscopic black holes, though currently theoretical, represent some of the most intriguing concepts in modern physics. These entities are astonishingly small, trillions of times smaller than a proton, and may have formed during the universe's earliest moments or through high-energy collisions. Unlike the massive black holes known for devouring stars, these are tiny distortions of spacetime at the Planck scale, existing where quantum mechanics and gravity intertwine. The concept of microscopic black holes suggests spacetime might be speckled with these anomalies, constantly appearing and vanishing within the frothy quantum foam that underpins reality. Exploring these black holes allows us to glimpse a realm where the very fabric of existence is stretched to its limits. Understanding them could bridge the gap between quantum physics and the vastness of the cosmos. Could these infinitesimal entities reveal the key to the universe's grand design? The answers lie hidden, waiting to be uncovered. The concept of microscopic black holes arises from the profound intersection of quantum mechanics and gravity. At this juncture, our understanding of the universe's smallest and most fundamental elements transforms. Theoretical frameworks like string theory and quantum gravity models propose that spacetime, rather than being smooth and continuous, could be a frothy expanse at the smallest scales, a phenomenon termed quantum foam. Within this froth, the fleeting existence of minute black holes becomes plausible. Stephen Hawking's groundbreaking work on black hole radiation and spacetime dynamics significantly shaped this idea. Hawking suggested that the universe at its most granular level might consist of dynamic, ever-changing structures where microscopic black holes could momentarily form and evaporate. These insights not only support the theoretical existence of such entities, but also invite us to rethink the very fabric of reality. Could these tiny black holes unify the seemingly disparate laws of quantum mechanics and general relativity? As we delve deeper, the implications promise to be as transformative as they are profound. Let's continue unraveling the mysteries surrounding these enigmatic entities. What if microscopic black holes exist, hidden within the very fabric of matter? Such an idea could fundamentally transform our understanding of the universe. Imagine every particle harboring a black hole, influencing its mass, energy, and interactions. If real, these black holes might redefine the properties of matter itself. Their behavior could unlock secrets about the universe's basic building blocks. However, detecting them poses a monumental challenge. They would be incredibly fleeting, vanishing almost instantly in bursts of Hawking radiation. Instead of direct observation, scientists would need to identify subtle anomalies, like unexplained energy losses in high-energy experiments. If confirmed, this discovery could bridge gaps in our understanding of quantum mechanics and gravity, reshaping physics itself. Could these elusive entities explain the fundamental forces governing our reality? As we ponder these possibilities, we delve deeper into the mysterious interplay of the cosmos' tiniest and most profound elements. The answers might forever change how we perceive the universe and our place within it. As we consider the profound possibility of microscopic black holes existing within every particle, a new perspective on the universe emerges. Imagine a cosmos where each particle is a gateway to infinite depths, revealing secrets far beyond our current understanding. Could these black holes hold the keys to the mysteries of space-time, gravity, and the very fabric of reality? If true, such revelations challenge our perception of existence itself, suggesting that the essence of the universe may not be light or matter, but an enigmatic darkness. This darkness might not signify void or absence, but instead an intricate complexity, a hidden structure underpinning everything we know. As we conclude, let's embrace the wonder of these possibilities. Each particle could be a portal to infinity, and the universe might be a tapestry woven with unseen forces and dimensions. The journey into understanding these concepts is just beginning, filled with awe and endless curiosity. What lies at the heart of everything? Perhaps it is the dark, a profound and beautiful enigma waiting to be explored.